Welcome to the next session on Advanced ANSYS Workbench tutorials. In this session, we will analyze the 90-degree bent pipe for its thermal analysis. We will start by double-clicking on Steady State Thermal. We'll first go to Engineering Data, Engineering Data Sources, General Materials. I'll choose stainless steel as one of the material. And the other material that I'm going to choose is HDPE, for which I'll give the value of isotropic thermal conductivity in watt per meter Kelvin. So this value is 0.51. Next, I'll go to Project and Update Project. Next, I'll go to Geometry and right click and import the geometry of the 90-degree bend. Then I'll go to Model and double click. Next, I'll go to Geometry. I'll select Solid. I'll change the material to stainless steel. Then I'll go to Mesh. I'll give the element size as 0.01 meter. This is in mm, so I'll change this to meter, 0.01, and then generate. Next, I'll go to Steady State Thermal, right click and insert temperature. On the inner surfaces, I'll give temperature, apply. This is say 50 degrees Celsius. Right click, insert convection on the outer body. The film coefficient is say 35 watt per meter square degree Celsius. I'll give the ambient temperature as say 24 degrees Celsius. Next, I'll go to solution, right click and insert thermal temperature. Again, I'll right click, insert thermal total heat flux. I'll go to solution and solve. So now you can see here the temperature variation. Inside it is 50 and outside the temperature is 49.842. On this surface here, you can see the variation of temperature. So you can just go to solution and insert thermal temperature on this surface. Just select the surface and change geometry from all bodies to one face. And you can just solve once again. So when you click here, you will be able to see the temperature change on this face only. It is actually about the thickness of the pipe where the heat transfer is taking place. So once you can see this, you can also see the total heat flux. Now if you want, you can change edges to no wireframe, contours to smooth contour. So now here you can see there is a maximum heat flux of 1003.2 watt per meter square. And minimum is 882.76. So maximum, minimum, you can see inside is maximum, here it is minimum. Now we'll go to solid and change the material to HDPE and solve once again. So we'll go to temperature. Let's see, your outside temperature is 46.024 degrees Celsius minimum and inside is 50. You can check here, there is a variation of temperature. This is minimum, inside is maximum. You can see the total heat flux, which is maximum inside 855.03 watt per meter square, and here it is minimum of 758.85 watt per meter square. So this shows how your heat transfer will take place in a 90-degree bent pipe. You can click on max, min and remove those tags. So with this, I end the session. I hope you understood the solution. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.